We are continuing with the equations of a straight line. Here A, B and C are the vertices of triangle ABC. Okay, so we have a triangle ABC whose vertices are 1 and 2. B is -3 and -4, and C is 5 and -6. Okay, he wants us to find the equation of the right bisector of BC. Okay, so what does that mean? It means that we have to drop a perpendicular to BC, and this perpendicular divides BC into two equal parts. In other words, you can say that you have to find the right bisector of the side BC. Right? A perpendicular which divides BC into two parts. And it's not necessary that this right bisector will pass through A unless it's an equilateral triangle. This right bisector will pass through A only if our triangle is an equilateral triangle, but that's not mentioned here. So we cannot assume that this right bisector, of which we have to find the equation, this is our required line, will pass through A. Fine. Now, we know how to find these coordinates. This is now the midpoint of BC. Now, let us name it as M. And we can find the coordinates of M as, if this is my x1, y1, this is my x2, y2, x1 plus x2 by 2 and y1 plus y2 by 2. Right? So the coordinates of M will be 3 plus 5, that is 8, divided by 2, that is 4. Minus 4 minus 6, that is minus 10, divided by 2, that is minus 5. So we got the coordinates. See, if it would have been passing through A, then it was very simple for us to find the equation of this line. We could have used 2-point form. One point was here and another was A. But it is not, because it's not given that the triangle is an equilateral triangle. So now we got the point. What do we require? We require slope. We don't have slope. But yes, we can find the slope of BC because this required line and BC are perpendicular to each other and the product of their slopes is -1. So we will find the slope of BC, then multiply both the slopes, put that equal to -1. We will get the slope of this required line. So let's find the slope of B is 3 and -4 and C is 5 and -6. So this is my x1, y1, this is my x2, y2. So slope of BC will be y2 minus y1 upon x2 minus x1, which is -6 minus of -4. So that becomes +4. x2 is 5 minus 3. So this becomes -2 by 2. So this becomes -1. So the slope of this is -1. Slope of BC is -1. Therefore, slope of required line will be +1, because if you multiply these two slopes, the product is -1. So one slope is -1. So another slope will be 1. Point also you have M as 4 and -5. So you can find the equation of a required line now. This is x1 and this is y1. Therefore, equation of a required line will be, or you can say right bisector of BC is y minus y1 equal to m times x minus x1. So y minus, this becomes plus, equal to 1 into x minus 4. So y plus 5 equals to x minus 4. Shift these to this side. So you will get x minus y. Minus 4 minus 5 equal to 0. So x minus y minus 9 equal to 0 is the equation of right bisector of BC. Fine. We have answered the first part of the question. Find the equation of the right bisector of BC. Now, similarly, he wants me to find the equation of right bisector of CA. Right. So I have to drop a perpendicular here. So this side will be equal to this side. So I can find this point. Let this be L. So how do I calculate the coordinates of L? I know by now x1 plus x2, that is 5 plus 1. 6 divided by 2 is 3. Then y1 plus y2, 6 minus 2 is minus 4. Minus 4 divided by 2 is minus 2. So you got the coordinates of L as 3 and minus 2. Now you need a slope. How do you find the slope? You will find the slope of AC, and then automatically you can find the slope of this line, which is your required line now. So let's find the slope of A, which is 1 and 2, and C, which is 5 and minus 6. So this becomes your x1 y1, this becomes your x2 y2. So slope is y2 minus y1 upon x2 minus x1. What is your y2? Minus 6. What is your y1? Minus 2. What is your x2? 5. What is your x1? Minus 1. So minus 8 upon 4. 4 2s are, so minus 2 is the slope of AC. Therefore, slope of the required line, this time required line is the right bisector of AC, is equal to plus 1 by 2, right? So you have found the slope of the required line. You also have the point through which the required line is passing. So now you have point as 3 and minus 2. You have slope as 1 by 2. You can find the equation of right bisector of AC as y minus y1 equal to m times x minus x1. So y minus, this is your x1, this is your y1. So this will become plus 2 equal to m is your half, x minus 3. So cross multiply, 3y plus 4 is equal to x minus 3. Let's shift all of them to this side. X minus 3y minus 3 minus 4 equal to 7. So we got x minus 3y. Oh, have we made any mistake? This is 2y. Sorry. This is 2y. X minus 2y minus 7 equal to 0. 2 into y is 2y. 2 into 2 is 4. I had written 3 here. So you have x minus 2y minus 7 equal to 0 will be the equation of the right bisector of AC. Right? That's also done. Now he wants us to find the coordinates of the circumcenter of triangle ABC. So what is a circumcenter? Circumcenter is the point where all the right bisectors meet, right? So that is the point of intersection of these two lines, right? Now we have the equations of these two lines. One is this, another is this. We can solve these two equations simultaneously to get the values of x and y. Fine. So let's write these equations. What are these equations? One is x minus y minus 9 equal to 0, and another equation is x minus 2y minus 7 equal to 0. X minus 2y minus 7 equal to 0. Fine. Now these will give me, this is my circumcenter now, and if I solve these two, I will get the coordinates of the circumcenter. Okay. So how will I do that? X minus y equal to 9, x minus 2y equal to 7. If I subtract them, this will be minus, this will be plus, this will be minus, this will go. So this will be y equal to 2. Fine. I got y as 2. Now I can find x. So x minus here 2 equal to 9. So x is equal to 9 plus 2. So my x is equal to 11. So what are the coordinates of circumcenter now? I am repeating again, circumcenter is the point where all the side bisectors of the triangle meet. So 11 and 2.